Alright, so have a look at your tutorial question. Okay, the second question asks you to draw all the possible structural isomer, and then you have to identify the types of structural isomerism present for molecular formula below. Okay, so we have several molecular formula given. Okay, if you still remember the definition of structural isomers, okay, the structural isomers is defined as molecules that have same molecular formula but different structure, right? So for the first molecular formula, we have C5H12. C5H12, the general formula for these molecules is CnH2n plus 2. So let's say the n here is 5. Okay, 5 times 2 is 10 plus 2 is 12. Okay, so the general formula is CnH2n plus 2. The CnH2n plus 2 is an alkane. The class of compound is alkane. Since alkane does not have a functional group, so we won't have a positional isomer, and also this general formula cannot form a functional group isomer. Okay, the carbon is 5, so we might have a chain isomer. Alright, so first step, okay, draw the longest carbon chain. Okay, so we have 5 carbon here, so we are going to draw the longest carbon chain. So I'll be use a skeletal structure. 1, 2, 3, 4, 5. So we have 5 carbon. 1, 2, 3, 4, 5. For the second structure, we are going to minus 1 carbon, okay, so that we have 4 longest chain. Okay, so 1, 2, 3, 4. And then for the fifth carbon, okay, we are going to make a one branch. So you can put it on the second or the third carbon here, but it still will give you the same structure. Okay, so if you put the one carbon on the third carbon here, okay, we are going to number it from right to left. It's still on the second carbon. Next, let's try to shorten the carbon chain into 3 carbon. So 1, 2, 3. So we need 2 other carbon. Okay, we are going to put the 2 other carbon on the second carbon like this. Okay, so we still have 5 carbon. So for the C5H12, we have 3 isomer, where the 3 isomer here is a chain isomers. For the second molecular formula, we have C4H8. Okay, so the general formula is CnH2n, where the CnH2n, it can be an alkene and also a cycloalkane. So since we have two possible class of compound here, so this molecule can have a functional group isomer. All right, and the functional group for alkene is carbon-carbon double bond. We might have a positional isomer as well. Okay, and the carbon here is 4 carbon. We can have a chain isomer as well. So let's draw the first structure for C4H8. Okay, we draw the longest carbon chain first. Okay, and I'll be use an alkene as my first structure. Right, so we have 1, 2, 3, 4 carbon, and alkene must have a carbon-carbon double bond. So let's say I'll put the carbon-carbon double bond between carbon number 1 and carbon number 2. So we have one structure. Okay, next I'll try to use the same structure, but I'm gonna minus the one carbon. Okay, I'll so that I'll have a chain isomer for this structure. Okay, so we have 1, 2, 3 carbon. Okay, and then the carbon-carbon double bond is still on the first and second carbon. The fourth carbon I'll put on the second carbon. Okay, so we have two structure now. So this two is the chain isomer. Next, focus on the first structure here. Okay, the position of the carbon-carbon double bond is between carbon number 1 and carbon number 2. Okay, if I still use the same longest chain, okay, for carbon, alright, so 1, 2, 3, 4, but now I'll change the position of the carbon-carbon double bond. Okay, so I'll put it between carbon number 2 and carbon number 3. So this is a positional isomer because I changed the position of the functional group, which is my carbon-carbon double bond. But for this structure, if I change the carbon-carbon double bond here or here, it's still gonna be the first and second carbon. Okay, because it is symmetrical. So there is no positional isomer for this structure. Next, I'm gonna make a functional group isomer from these three structure. Okay, since this one and this one, the longest chain of carbon is 4. Okay, the cycloalkane that have 4 carbon have a square shape. Okay, which is we call it as cyclobutane. Okay, we have 4 carbon here, square shape. Okay, but for this carbon, the longest chain is 3. Okay, the cycloalkane that have 3 carbon, the shape is gonna be triangle. Okay, so we have 1, 2, 3 carbon, and then another carbon, it's gonna be our branch, our substituent. So in C4H8, we have 5 isomers. Okay, let's label our isomer, and then we are going to identify the type of isomer present. Okay, so we have a chain isomer. Chain isomer is only for structure A and B, right? And then for the positional isomer, okay, the positional isomer only for structure A and D. Okay, last but not least, we have a functional group isomer. Functional group isomer is for structure A, D, and E. Also, we have B and C. Next, let's have a look at C3H8O. So the general formula for this molecular formula is CnH2n plus 2O. Okay, so here from the general formula, we know that the CnH2n plus 2O, it can be an alcohol and also ether. Right, so since we have two class of compound here, so we know that this structure can make a functional group isomer. But then we have only 3 carbon, okay, so it won't have a chain isomer, right? So, and also we have a functional group here, it can have a positional isomer. Right, so let's draw the first structure for alcohol, okay? So let's say this one is 1, 2, 3. We have 3 carbon, and then let's put the OH group on the first carbon. Okay, so we have our alcohol here. Okay, so since we cannot have a chain isomer, alright, so let's change the position of the OH group to the second carbon so that we have a positional isomer. Right, so we have 1, 2, 3. Okay, so now let's have a look at this structure. Okay, we are going to change from alcohol into ether. So the functional group of ether is COC. So the O is going to be on the center, and then we have carbon. Okay, so let's say we have 1, 2, 3 carbon here. Okay, this one is the third carbon. So we still have 3 carbon, 8 hydrogen, and 1 oxygen. Okay, if you change the position of O between carbon number 1 and carbon number 2, it still gives you the same structure. So for this structure, we have only 3 isomers. So A, B, C. Okay, and then we don't have a chain isomer, but we have a positional isomer, which is between structure A and B. And then the functional group isomer is between structure A, B, and C. For the fourth molecular formula, we have C4H8O. So let's have a look at the general formula for this molecular formula. So we have CN, H2NO. So from this general formula, okay, so we know that it can be an aldehyde and also a ketone. So since we have two different class of compound, it can make a functional group isomer. Okay, the number of carbon is 4, so we might have a chain isomer, and also we have a functional group, so we might have a positional isomer as well. So let's draw the first structure. So let's say I'll take an aldehyde. So we have 4 carbon, 1, 2, 3, 4. So let's label it 1, 2, 3, 4, and then let's put the double bond O carbon C double bond O on the first carbon. Okay, so this is an aldehyde. So for aldehyde, we have to remember that for aldehyde, the C double bond O must be on the terminal carbon. Okay, dia kena duduk kat hujung-hujung. Sama ada awak letak dekat nombor 1 or on the fourth carbon here. But still, it will give you the same structure. Okay. So that is for aldehyde. So this one is for the longest chain carbon, 4 carbon. So let's minus 1 carbon so that we have 3 carbon as our longest chain. Okay. And then our C double bond O, let's still put it on this carbon. Okay. And then for the fourth carbon, put it on the second carbon so that we have a branch. Okay. Still an aldehyde. So we cannot shorten the carbon chain anymore. Okay, so these two are a chain isomer. We cannot change the position of C double bond O into the middle because it will give you a ketone. Okay, if you change the C double bond O on the second or the third carbon, it will give you a ketone. So it is a functional group isomer, not a positional isomer. If you change the double bond O into the fourth carbon or here on the third carbon, it still gives you the same structure. Okay, because from right to left or left to right, okay, it's still the same, right? So let's change it into ketone. So take the longest chain, 4 carbon, right? 1, 2, 3, 4. And then put the double bond O into the second carbon or the third carbon, still give you the same structure. Okay, so we have a ketone. Okay, for this structure, can you make it as ketone? Okay, let's try. Here we have 4 carbon and then try to put the double bond O here. Is this structure correct? No, it is not, because now this carbon have 5 bond. Okay, it's exceed the maximum number of bond that carbon can have. So no, this structure does not exist. Okay, so you cannot change this structure into a ketone. Okay, so we only have 3 structure for this molecular formula, A, B, and C. So we have a chain isomer, okay, chain isomer, which is between between structure A and B. And then we don't have a positional isomer for this molecular formula, but we have a functional group isomer, which is structure A, B, with structure C, because A and B are an aldehyde. Okay, C is a ketone. Last but not least, we have C4H8O2. So the general formula is CnH2nO2. So from this general formula, we know that it can be a carboxylic acid or an ester. Okay, so we have a functional group isomer for this structure, and we might have a chain isomer, and also we might have a positional isomer. Okay, let's draw the first structure. So let's say I'll draw the carboxylic acid. The longest chain of carbon is 4. Okay, 1, 2, 3, 4. And then I'll put the double bond OOH on the first carbon. Okay, so we have C double bond OOH. So this is a carboxyl group. Okay, so this compound is a carboxylic acid. Okay, so let's try to change the carbon chain, the longest carbon chain, into 3 carbon. Okay, 1, 2, 3, and then put the fourth carbon on the second carbon. 1, 2, 3. Okay, and then put the double bond OOH on the first carbon. Okay, so we have two structure now. Okay, so we cannot shorten the carbon chain anymore. So let's change this one. Okay, the carboxy group is same like an aldehyde. It must be on the terminal. Okay, so you cannot put it on the middle. If you put it on the middle, it will become an ester. Okay, because the carboxy group is C double bond OOH. Okay, so it does not have a positional isomer. So let's change this into uh, an ester. Okay, so let's say we will put C double bond O, and then C. The functional group for ester is C double bond OC. Okay, so we have 1, 2, 3 carbon, and then put another one, 4 carbon. Okay, this is an ester. So here we have 2 carbon on the left, 2 carbon on the right. So let's say we change the position of C double bond O like this. 1, 2, 3. Now we have 3 carbon on the left and 1 carbon on the right. So these two is a positional isomer. And let's label our structure. Okay, so we have a chain isomer. Okay, our chain isomer is between between structure A and B only. And then for the positional isomer is between structure C and D. And the functional group isomer is between A, B and C, D. So that's all for structural isomer.